guys, if the sound went out on the last video, I apologize. Um, but we're going to walk you through this to help you complete it. You do need to make this why your properties of your quadrilaterals are very important because I have a kite here, the diagonals of a kite are perpendicular, and your short diagonal gets bisected. Okay, so because of that, right now, and since I know, and I went ahead and labeled it that, what was it? IE had to add the E was 2A. That lets me know that each piece here has to be A. Okay, AA gives me a total of 2A. And then, so they want us to come up with the vertices for the figure using those properties. So remember, I'm using my equal distance for those things that are about the origin. And then we have the other parts, our horizontal distance and our vertical distance. So if I'm looking at I is right here on the y-axis, so that would have to be 0. And it has a vertical distance of A. Okay? If I'm doing T, it's on the x-axis, so it has to have the horizontal distance of C and then 0. E on the y-axis, so we're looking at 0 and then negative A, same distance. K on the x-axis has the distance, a horizontal distance of B, and then that would be 0. So that kind of pretty much takes care of that. Help you on that problem. Now, I just need you to, these are the key concepts we're going to have to use. I need you to try number 9 and 10. That goes back to our examples 1 and 2, and then the guided practice that you did on 2 through 7. So just check to see. Hopefully, these get straight to the point. For example, K, and I'm just going to write it here. K was negative A, comma B. M was A, comma negative B. And N was negative A, comma negative B. Now, this problem here went with example 2, where, remember, to get to this point R, I'm going to use my vertical and my horizontal, my slopes, because they would have the same slope. Okay? So I know that right here, rise over run, remember this piece is the same right here. And if I already know that this piece is S, okay, so that means right here, from here to S, from here to here is S. So if I want to find, and I know this is my, what was that? That was my C. So right there, if I put those together, boom, you see together, that has to be S plus B. Okay, that's the distance, my horizontal distance. My Y is my vertical distance, which is the same as R, which would be C. Okay, sorry about that. So I hope that will help you with that. Watch it again if you need to. Now, we're going to walk through this. This is very important, making sure you understand what you have to show. Remember I was showing that opposite sides are parallel when we're dealing with parallelograms? Okay. So if I want to show, and we kind of just did it on number 10, I want to show, explain why the x-coordinate of B is the sum of 2A and B. Well, basically what you have to state is that our distance from A is 2A. And we know that distance is the same because opposite sides are congruent in a parallelogram. Okay. But right now we know that that distance is the same here. So we're going to use our rise over run. So our rise here is 2C. And our run, this B right here, I mean this blue line, represents 2B. Okay. Which we know is the same as this piece right here, 2B. So if I put them together, the distance, the whole distance, 2B, is the sum of 2A plus 2B. Okay? Alright, so you might need to make some room in your spiral for this. I'm going to just scroll down and show you this, but this is where our prerequisite skill check is important because you have to do some multiplying with a binomial. So since I've given this fact that we know is telling us is a sausage trapezoid, so the diagonals are congruent. For RD has to be congruent to AT, so you have to use a distance formula. We're going to use a distance formula with the variables that we have for our coordinate. So RD, we're going to start with here, this distance, or sorry, RP. Did I write RD? We're going to change that. That should be RP. Apologize. All right, so the distance from RP, using the distance formula, is your change in your x coordinates, okay? X2 minus x1, so that's a minus a negative b, parentheses squared, plus y2 minus y1, 0 minus c, parentheses squared. And now we're going to simplify it, okay? So I'm going to show simplification two ways. I'm just looking at simplifying parentheses, order of operations. So this is really a plus b, parentheses squared, 0 minus c would just leave me with the negative c, parentheses squared. And then when I simplify, I'm just going to do two more steps here. A plus b, parentheses squared, plus c squared. Because anything squared becomes positive. Now, I do want to talk about this grouping right here. This is why I asked you to do your prerequisites. Go. So if you were using the box method to simplify this, you would do A and B, A and B. And then you would do your multiplying. So we have A squared, and then we would have AB, because A times B is AB. Then we would have AB, and then we have B squared. So if I were to combine my like terms, I have A squared plus 2AB plus B squared. So I could show that all combined, write that here as A squared plus 2AB plus B squared, because that was what that was, plus RC squared. Okay? So what we have to do is check if our expression is the same, because this is RP, for our diagonal AT. So I'm just going to extend this page here. We're going to work it out. So AT, using the distance formula, is B minus a negative A, parentheses squared, plus C minus 0, parentheses squared. And then we're going to simplify that. That actually becomes B plus A, parentheses squared, plus C, parentheses squared. Now, I want to show you something real quick. Okay? You should know how to simplify this part. Sorry. Using the box method. But we're just going to stop real quick, because what I want us to go back to is right here. I'm going to bring this down. This is what we had for RP, okay? And I'm hoping you recognize right now we're showing congruency because addition is commutative, meaning I can change the order and I'll have equal relationship. 3 plus 2 is the same thing as 2 plus 3. So A plus B is the same thing as B plus A. So right now I have proven that AT is congruent to RP. And if those diagonals are congruent, then it's isosceles. Okay, so I'm just basically, we just rewrote this right here as A plus B. We just put it in, switch the order. It's the same thing. Okay, I don't want to confuse anybody. All right, so you will definitely see something like that. We'll ask you to do that on your test this week coming up. So we need you to add the work. We're going to add the examples on a separate sheet of paper. Okay, I'm going to pause or have you go fast forward to the playlist so we can complete example or problem 12, and then problem 13 will be a separate video as well. Okay, thank you.